In this video, we are going to be investigating scale drawings and models and how those relate to our proportional reasoning and strategies for solving proportions. Okay, so first of all, what is a scale model or a drawing? So basically, it's just an enlarged or reduced, meaning I can scale something to make it bigger or I can scale it smaller, or reduced version of something similar to the actual version. Okay, so when I say similar, I mean similar in the mathematical terms. So similar meaning the proportions are the same. So I don't mean similar like, oh, it's the same color or it's the same vague shape. It means that the dimensions of the thing have a consistent either enlargement or reduction in scale. Okay, so we are able to do this by using proportions. So I'm gonna write that big here, proportions. So we're going to use those proportions. Okay. So imagine we have a situation where we are thinking about the actual Big Ben. This is a famous landmark or monument in London, and we have a little scale model of it over here on our nightstand. So I'm going to go ahead and sketch my little scale model. Here we go. Here's my scale model of Big Ben. I know it's like this clock tower. There it is. Okay, I've sketched it. So the actual one is 272 feet tall, and I might use the notation of a colon to show the scale. So I'm going to write here. So this is this, scale. Try with a C. There we go, scale. So I know that my scale for this little model to the real one is 1 to 32. So that means 1 inch is 32 feet. So 1 inch on my model is 32 feet in real life. That's gonna be the scale. So I'm gonna take that and I'm going to use that, what I already know of 272 feet, and I'm going to write it as a proportion. Okay, so how do I go about doing that? Okay, so I'm going to use this little space over here. I'm going to take my scale, 1 to 32, and I'm going to set it up 1 to 32 as a ratio, and I'm going to set it equal to, and then I have to figure out what do I already know. So I know that the real version, the actual version, is 272 feet. And in my scale, the 32 is the actual. So I know that when I set it equal to the other side, that 272 needs to be in the spot of the denominator to show that that's what it's equivalent to. And so I know that the unknown value that I'm going to solve for, there we go. I'll just put it h. There's my variable. Actually, maybe I should put it in a different color. H. I'm going to solve for h. So this is going to be what is the height of my model. Okay, so I'm going to go ahead and use my strategies for solving proportions to figure out the value of that. So I'm going to use my proportional reasoning and think, if I'm making my denominator, if I'm going from 32 to 272, how many times greater am I making it? And whatever that scale factor is, I'm going to use it and apply it to my other one. So times how many? So times whatever that mystery number is. All right, so I'm going to show some computational work up here. So I have 272. I'm going to divide that by 32 because I know 32 times what is 272. I can manipulate that equation to make it division. And I am going to, 32 is in 272. I know that's going to be 8 times. 8 times 2 is 16, 24, 25. Do a little long division here. 61, bring down the 0, 32 goes into 160, that is gonna be 5, so 8.5. So I know that my H value is 8.5. So that means that my little model of Big Ben, right here, that's sitting on my nightstand, this guy is 8.5 inches tall because it is a scaled model with the 1 to 32, or 1 inch for every 32 feet of this. So it is in that proportion. Okay, so I can use the same thinking and reasoning to solve for any scale model or drawing problem. So think of it like you're setting up your scale on one side of your proportion, and then you have the real measurements on the other. Okay, real measurements on the other side. So you're gonna put your map or your model, that scale. So is it 1 inch? Is it 1 millimeter? Is it one, whatever measurement on what they set the scale to, over the actual thing? So then that would be 32 feet. So in this case, it was 1 over 32. So that's your scale on one side. And then you put the real measurements on the other. So again, I'm gonna make sure of the real measurements, I put the map or the model in the same location, in this case, the numerator, and then the actual measurements on the bottom so that it matches. And whatever scale factors that I use for one, I use for the other. Okay, so let's go ahead and put this in another situation.